Okay, I'm trying to stay calm. Just got off that wonderful Google Meet where I was out on the deck. It was freezing. Alrighty, we're going to find this green zone. This is a normal curve, which means that we need to know the mean. You can't see that. You need to know the mean and the standard deviation. All right, we know the mean at 0.5 because that's what we're assuming. The standard deviation is our old formula, PQN. Notice there's no hat because we're building this off of the assumption that we got a P. So we're going to do the square root of 0.5 times 0.5 over n, which is 14, not very big. So this is going to be bigger than our normal standard deviations we usually get. Squirt 0.5 times 0.5 divided by 14.13. So if we're trying to find probability, we're going to do normal CDF of 0.43 to infinity and beyond. The mean is 0.5, and the standard deviation is 0.13. So I'm going to go to VARs. Remember, if you're on StatCrunch, it's even easier than this. Yep, because I'm still trying to get to the screen. So infinity is like a million bajillion, right? Times a million bajillion. 0.5, 0.13, 70. Okay, so there's a 70% chance that the sample you'll get from 14 people is at least that, assuming that the mean is 0.5. That's way too high. Too high to reject. So we're not going to reject. I'm going to type our conclusion here. So we fail to reject the claim that we fail to reject the idea that p is equal to 0.05. There is not sufficient evidence to reject the claim. So we have to kind of stop there. We can't say much because we aren't saying that the p is 0.5. We're saying that we can't say it isn't. The double negatives is a lot of fun. Okay. I'm going to save that so that way you can have it again. Are we still recorded? We better be. Caputo mad. Okay. So we're going to do this problem here. I'll read it out loud. Through a sample of the first 49 Super Bowls. Hey, look, football. Now I'm engaging a third of you. 28 of them were won by teams in the National Football Conference. So there's 2 leagues in the NFL. Use a 0.05. There's our alpha. Significance level to test the claim that the probability of an NFC team Super Bowl win is greater than 1/2. I'm going to underline greater than 1/2 because I think we found our claim. So alpha is 0.05. What else can we pull from this? So the first thing we always do is look at that claim and we identify our null and our alternative. So our null, P, probability, P, proportion, all the same thing, equals the number they give us. And, oh my goodness, this is the same problem we just did, just a different context. Okay. We're going to find... So there's a couple of ways to do this, and I realized that the probability way is tricky. So we should first identify the p hat. What did our sample actually give us? Maybe it'd give us n. Our p hat was 28 out of 49. So 0.57. What's that? 4/7. Just kidding. Okay. Yeah, 4/7. Yeah, it is. Okay, so 0.57. N is 49. Okay. So based on our null hypothesis, we're assuming Wait, do we have all of our requirements that, yep, the x is more than 5, definitely, and the opposite of 28 out of 49 is definitely more than 5. So we're good. Same thing. We got a 0.5. The standard deviation of this will be smaller because of that, because we're going to divide it by something bigger. We might as well find that right now. Notice I'm going to use P and Q, not P hat and Q hat. Over 49. .07. 0.071. Let's go one more decimal place than I got right here. Okay, what else? So we're doing a 0.05. What kind of test are we doing? Well, I have a greater than, so I got a right-tailed. All right, so I'm going to put that 0.05 here. So there's a couple ways to do this. We can find the probability that when the probability is 0.5, we get 28 out of 49 or more than that. It might be easier just to identify what is that number right here. What is this z-score that makes 0.05? And then we'll find out if 28 out of 49 is more than that, okay? So here's our rejection zone. That's your 0.05. Why don't we find... and the way we're going to do that is inv norm, okay? Or it's easier on the StatCrunch. More people probably have access to StatCrunch. Let's practice some StatCrunches. Oh, look, there it is. StatCrunch. Well, we're going to do little, calculators. Notice how that says z-stats, proportion stats. This will run the hypothesis test for us. I'll do it without, and then we'll do it with. Normal, standard. The mean here is 0.5. The standard deviation was 0.071. And we want to do a greater than 0.5. 0.05. Boom. Okay. 0.6162. So the z we just got 0.62. So we want to find out, does our p hat, where does our p hat go? Oh, okay. Whoa. P hat is right there. Actually, I'm going to do that in green because that's our sample. Just, colors. So are we going to reject, or did we fail to reject? Since, I'm going to write it a little smaller. Since 0.57 is less than 0.62, technically it's not greater than. But doesn't not greater than mean? And if it was equal to 0.62, we reject. It would be impossible to be equal, because all those decimal places, but that's the deal. We failed to reject. The null. There is not sufficient evidence to support the claim that the proportion is greater than half. So the idea is 0.57 wasn't extreme enough. Think about what I just said. It wasn't far enough from 0.5, based on this level of 0.05 here, to reject. So we failed to reject. Now, there's something that you could do as a researcher is just increase your significance level. We're going to see 0.1 significance level. That doubles it. That probably will reject it, but that basically increases your error. There's an error here that we're going to learn next week. That, has to do with the fact that, you might have just made a mistake. Like, this is close to 0.5, but there's still a chance that the proportion is not 0.5. It might be bigger than that. So there's different types of error we can make, and we're going to learn that in due time. Save. Problem number 2. That was proportions. Let's see what this one has us do. Okay, statistics students estimate the length of 1 minute without reference to a watch or clock. You might have done this before. You know, we all say, okay, I hit time, and then if we were in class, we would have clapped or something when you thought a minute has gone by. So here's a sample of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I might have gotten that wrong. 1, 2, 3, 4, 5. 5. Yep. Why would the textbook give 14 and not 15? It probably says 15 up there somewhere. I'm just not paying attention. Okay. I see a 0.05. Hello, Alpha. I see a claim. I don't see any greater than, less than, equals, so a mean of is equals. So we're claiming the null, which is a tough look. It's a tough thing to claim the null, because all you can do is either reject it or fail to reject it. So what are we really doing here? We got our alpha 0.05 per usual. We got a null hypothesis of equal to 60 seconds. But wait, what symbol we're using? We're not p, because it's not proportion. Oh, I see the word mean. You always make a claim about a population. Okay? And then, wait, it doesn't say greater or less, so what's the opposite of equal to? Not equal to. Which means two-tailed. Essentially, that means we're making, that's a little equal arrow. We're going to make a confidence interval. That's essentially what we're doing. We're going to make a confidence interval at 60 based on all the data it gave us, and if our sample comes out of that, then we reject. If it's inside that confidence interval, that means we actually think that 60 might work. Okay? So what did it give us? X bar was, it just gave us data. So what do we need? We need X bar. I'm using the formulas that we learned in the last unit. We need S and we need N. Well, I have N at 15, but I don't have X bar. Well, enter StatCrunch. Can someone read me the data that I had? Hello? Hello? Oh, yeah, I'm recording because my internet sucks. That's right. It's great. It's wonderful. I really love my job. Where'd it go? 8.3. Yes, I'm using the textbook. I'm not creative enough to make problems up. Actually, that's not true. But okay, so I'm going to type in var1, variable 1, 69, 81. Remember, we used to do this on the T9 calculator too. TI-83, 84. We used to go to edit. 65, let's see, 42, 21, 60, 63, 66, 48, 64, 70, 96, 91, 65. Okay. Maybe I'll highlight. No, I think all we got to do is calculators. Summary stats might be really good.